Alrighty, guys. So we're on our last lesson for Unit 6. Today we're going to talk about proving uh, things in the coordinate plane, so proofs using coordinate geometry. Um, and I'll go ahead and tell you this video lesson is probably going to be a little bit longer because I'm going to do a lot of talking and setup so that hope you are fully prepared to do your homework. I've tried to model these notes as close as I can to the homework. Um, And as I go through, I'll tell you what I've given you so that you should be able to do this. Okay, there's no reason you shouldn't be able to do this unless you're just confused on a piece of it and need help on that. But all right, let's get started. So there's one theorem we have to talk about, and it's the last one in this chapter actually. It's about trapezoid mid-segments. Okay, so remember, hopefully in part A you talked about the mid-segment of a triangle, but if you didn't, I can explain what it is here. All a midsegment is, it is a line segment that connects the midpoints of sides. So right here on this side AD, we're saying that E is the midpoint. And over here on side BC, F is the midpoint. And so when you connect those two midpoints, you've created the midsegment. Okay? Now the midsegment for a trapezoid has two important properties that we'll talk about. But let's label this as the trapezoid. So we know trapezoid has one pair of parallel sides, so I'm going to label my parallel sides. All right. So part 1 of the trapezoid midsegment says that the midsegment is parallel to both bases. Okay. So remember, the bases are the pair of parallel sides, and so this says that the midsegment is also parallel to it. So if these get one arrow, then guess what? The midsegment also gets a parallel arrow. Okay. You could have put it right here in between the two. I just put it over here because I've got the word midsegment written there. But just so you know that the base AB, midsegment EF, and base DC are all parallel. Okay? So we could say EF is parallel to AB, and EF is parallel to DC. Okay? Part 2, the midsegment is half the sum of the bases, of the lengths of the bases, let me say that. Okay? So however long both your bases are, you add them up, take half of it, that's how long your midsegment is. Okay? So if I were to write it out, EF is 1/2 AB. Remember, sum means to add. That's what it would look like. Okay? Now, why are we learning about this right now? Well, one hand of it, you could do some equations and algebra with it, but we're not going to do that right now. If we do, I'll add it later so you can see it. But what we're going to do is we're actually going to prove these two things. A semi sort of proof, like in the coordinate plane, okay? I'm going to prove the second one with you on this video. The first one is actually on your homework, so you'll have to prove the first one on your own. This one, I'm going to show you what to do. Okay? Let's look at these. So, we're going to prove this, the second part of the trapezoid midsegment theorem. And what I've given you is I hand drew this on a coordinate plane. Now, I know you can actually count where these coordinates are at. I don't want you to do that though. Okay, I don't want you to assign actual numeric values to all these coordinates, okay? We're going to use the coordinates I've given you right here. It ties back into what you did last week with just putting those figures in the coordinate plane, okay? So I've given you the coordinates right here of TRAP. So TRAP, that's the trapezoid. I've given you the coordinates, and I've given you a sort of a game plan to follow for the proof, okay? So first thing, we're going to find the coordinates of M and N. Notice M and N are the midpoints using the midpoint formula, okay? Then we're going to find the length of MN, TP, and RA. Why are we doing that? Because we'll go back up and look up here. Given MN is the midsegment of the trapezoid, we're proving that the midsegment is half the length of the two bases added together, okay? We're proving that this midsegment is half the length. So if I need length, this is my clue to use distance formula. All right. If you see length and we're talking about stuff like this, it's always distance. And then we're going to compare the lengths when we get done. So first thing I'm going to do is we're going to do the first step, find the coordinates of M and N. So I'm going to do it up here. M is in the midpoint of this side, T and R. So I'm going to use the coordinates of T and R for my midpoint, okay? Remember, midpoint says you take, okay, let's do it like this. Sorry, I had a brain fart there for a second. Midpoint says you add the X coordinates up and take half of them, and then you add the Y coordinates up and take half of them, okay? And if you don't remember that formula, you're going to have to either find it on Google or look back in your notes because I've given it to you before. All right. The x's of T and R, so 0 plus 2b divide 2. Now add the two y's up. 0 plus 2c divide 2. All right, clean this up. 2b plus 0 is just 2b divide 2, and then we get 2c divide 2. And then, because it's just 2b over 2, we can divide those 2's out, and so we get that M is its, oops, I wrote it backwards, is it B comma C. Okay, now let's do N. So N is in between A and P, so I'm going to use the coordinates of A and P. The X coordinate of A is 2. I'm going to start with P actually. I want to put my A first. A plus 2D. If you want to put D first right here instead of A, that's perfectly fine. Divide 2. And then 0 plus 2C divide 2. Now we need to clean this up. There we go. Now, this looks complicated. Obviously, we can't add anything on top because we can't add something with A to something with a D in it. That doesn't work. But do you notice how everybody has a 2 in them? And this is the only time you can do this, guys, is everybody's got a 2 in them. we can divide that 2 out. So we're left with A plus D, and then this will be 2 divided 2. This, I'm speeding things up here. This part right here is going to work just like this up here. So I'm going to like track that real quick. This will end up being C. All right, so now we have new coordinates for M and N. So now I got to find the length of MN, TP, and RA. So we're using the distance formula. And at this point, I expect y'all to know what it is. So if you don't, you're going to have to either Google it or look back at your notes because I'm not going to give it to you in this video. You have to know what it is. So distance is big square root. With distance, it says to start with the second coordinates first. So since N comes second, I'm going to start with it. The x of N, subtract the x of B. So that's going to be A plus D minus C. And then all of that is squared plus the y of N, subtract the y of M squared. Now, let's see if we can clean any of this up. So look inside here. Can you simplify any variables in here? No, because you got 3 different ones. So that part's going to stay the same. This one, C subtract C, that's 0. So that's really just gone. So we're going to write what we have left. All right. Now let's find the length of TP. So TP big square root. So since P comes second, I'm going to start with P. The x of P, subtract the x of T. So 2a minus 0 squared plus the y of P, subtract the y of T. 0 minus 0 squared. Zero minus 0, that's all going to go away. So we're left with 2a all squared because we have a 0 left. And then if we simplify that, you square everybody, so 2 squared is 4, and then a squared is just going to be a squared. Now let's find the length of RA, which is at the top. So RA equals big square root. Start with A. So the x of A, subtract the x of R. So 2D minus 2C squared plus the x of, oh, I can't read. I'm sorry. I wrote a C. That's supposed to be a B. There we go. Plus the y of A, subtract the y of R. This is going to end up being 0, so we can cancel it out. It's not just gone. This is going to stay there. Right, I had to check something real quick. I just realized I made another mistake right here. Let me fix it. I'm supposed to subtract the x of n from m, and the x of m was b. I can't read. I apologize for that mistake. There we go. Fixed it. Okay, now, I don't want to go into all the square root knowledge here for a minute, but see how everything underneath our square roots here are squared? Like everything's nice, really, and square, pretty and squared. So what's going to happen is we can just drop those off and take the square roots. So basically, whatever is squared is gone, and then we'll have a plus d minus b left right here. On TP, that's going to turn to 2a. And then right here, we're left with 2d minus 2b. All right? Now, let's see if we can verify this formula with what we've got here, okay? So mn is our mid-segment, so that's what we're going to put first according to that. So what did we get for that? We've got a plus d minus b equals 1/2. And then it doesn't really matter what order we put these in. Let's start with TP. So 2a plus 2b minus 2c. I can't read apparently today. I apologize. That's supposed to be a D. That's supposed to be a B. All right. Now, if you sit and stare at that long enough, you should notice that everybody in here has a 2 on them. And you take half of 2, you would get 1. So then we can see that we've done it correctly. Okay, so we just proved the second half of this theorem, that the mid-segment is half the sum of the lengths of the bases. Okay, and that's how you would prove it. The first part of the theorem you're going to prove on your homework. And I gave you a game plan, so just follow the game plan and you'll be fine. Now, what we're going to do next is we've got just some interesting things that I want us to prove using coordinate geometry, okay? And again, we're given something and we have to prove a certain thing. And I've given you the coordinates I want you to use. Again, don't assign numerical values to these guys. Use the coordinates I've given you here and follow the game plan. Okay? Now, I'm going to say it again, this video might be a little long, so if you need to pause it and catch up with me, that's fine. But I do need you to watch the whole thing through because you've got to know how to follow these proofs in order to do your homework. Okay. So we are given that ABCD is a parallelogram. Now, we did a lot of things with parallelograms, so I have to remember those. We're trying to prove that AC, I need to put my segment line there because I can't add that in myself. Segment AC bisects segment BD. and vice versa, that BD bisects AC. So let's look at that. AC is right here. Notice that is a diagonal. Is going to cut BD in half, and BD is supposed to cut AC in half. What are we proving here? We are trying to prove that the diagonals bisect each other, which remember is a property of a parallelogram. We're trying to prove that that works. All right. In order to prove that works, if these are cut in half, then what should happen is right here at point E, E should be in between both of these segments. Like it should be halfway between A and C, and it should also be halfway between B and D. Okay? If we can show that, then that tells us that this piece is congruent to this piece, and this piece is congruent to this piece. Okay? If we can prove that's true, then we know that they're bisected. All right, so let's see that. So again, we're using midpoint. And we're going to find it from AC. So we're going to look at A and C. Remember midpoint, let me write it over here just so you can see it. I said I wouldn't give it to you, but I lied. Remember midpoint is you add the x's up, divide it by 2. And then you add the y's up, divided by 2. Okay? So AC, we're going to use the A and the C coordinates. Let's call the midpoint E. The midpoint of AC, we're calling E. So we start with our x's. I'm going to start with C. So we've got 2A plus 2B plus 0 divide 2, comma. Now we'll do the y's. 2C plus 0 divide 2. Let's clean up. 2A plus 2B divide 2. 2C divide 2. All right. Notice that everybody has a 2 in it, so we can kind of divide that 2 out. So we're left with A plus B, comma, divide the 2 out there, we get C. Now let's see if we get the same thing. So let's do midpoint E of the segment BD. So we're going from B to D, so start with D, the x of D plus the x of B, 2A plus 2B, divide 2, comma, the y of D plus the y of B, so 0 plus 2C, divide 2. Okay, again, everybody has a 2, so we can cancel them out. A plus B, and then 0 plus 2C is just going to turn into 2C, and then that will divide out, so we go back at C again. Now step 3 is to compare the coordinates. So look at our coordinates. A plus B comma C, A plus B comma C. So we say the coordinates are the same. So the diagonals bisect each other. And that's the end of our proof. That's what we're trying to prove. Okay, here's what I'm going to do. If I keep going with this one video for all these notes, it's going to be forever long. So what I'm going to do is I'm going to stop this video after this problem. I'll make a second video doing the other two note problems. And that way it's not one big video you have to watch. You can watch pieces, all right? So make sure you watch this one first, and then you go watch the second one to get the rest of the notes, okay?